We're now going to take a look at how to apply the completable future timeout mechanisms that were introduced in Java 9 to solve a very similar problem for computing the exchange rate and the best price to fly from London to New York. This is a variant, it's a completable future-based version of something we just looked at with RxJava. So we're going to define a couple of fields. We have the default rate, which defaults to 1, which is unusual. You very rarely find British pounds and US dollars having a 1-to-1 exchange rate, but it could happen. We're going to run the test for 5 iterations, and we have a random number generator field, which will be used to generate random delays, which will evoke exceptions to occur. The main program just creates an instance of this class and runs it. Here's the run method. We go through iterations from 0 up to, but not including 5, because that's S max iterations. So we run 5 times from 0 to 5 without including 5. And then here's what we're going to do. We're going to go ahead and use the supply async method of the completable future to find the best price from London to New York. And find best price, as before, waits for some random delay and then returns a constant, just like the RxJava version did. And then also in parallel, we're going to go ahead and query for the exchange rate between the US and Great Britain in terms of pounds, so dollars and pounds. And again, we use supply async. Again, query exchange rate for, goes ahead and waits for some random delay and then returns the exchange rate. Obviously, the query exchange rate for and find best price methods are simulations of what would actually be a microservice in a real client server program. What we do here now for the exchange rate computation is we use a Java 9 addition to completable futures called complete on timeout. This was not part of Java 8. This came with Java 9. And what it does is it basically says, if this computation takes more than 2 seconds, just give it back the default rate. So that's, again, very much what we did with the timeout mechanism with RxJava. It's got a slightly different syntax, but the behavior is identical. We then go ahead and use the then combine method here, which is kind of the way we used zip in the RxJava example. So we take the best price completable future and the exchange rate completable future, and we say, when both of those things finish, then run the conversion operation, which just multiplies the price by the rate. Or we register a timeout. So this, again, is very much like the RxJava version. So what we're saying here is, if after 3 seconds, these computations haven't come back with the best price with the exchange rate, go ahead and throw the timeout exception. And then what we do is we kind of interpose or stick in the when complete method, which is one of the exception handling methods in completable futures. And we basically say, if the amount is not null, that means an exception didn't occur. So we print the price of the best price in pounds. Otherwise, if amount is null, then an exception was thrown and we print the exception name. So this is just the way you do these kinds of things with completable futures. Remember, with RxJava, we used the second parameter to blocking subscribe in order to handle the exception. Then we go ahead and we swallow the exception, because when complete does not swallow the exception. So if we don't want the exception to propagate out and cause the program to blow up, we have to convert it, and we just convert it to null. We don't really care what it gives us. And then we block until all the asynchronous processing completes. So we use join here instead of using blocking subscribe, which is what we had done for the RxJava version. So the rest of the code is pretty much the same as we saw before. So let's go ahead and run this, and hopefully it'll work, and we'll see what the results look like. They should look very similar to the ones we had for the RxJava version. So you can see here that if the whole thing times out, we get a timeout exception. You can see if the, and it printed out what the exception was. You can see here if we had a timeout looking up the exchange rate, then we get back an exchange rate by default of 1. So this is the price for that. And if we are able to look up the exchange rate in under 2 seconds, and if the whole thing takes less than 3 seconds to run, then we multiply the exchange rate, which comes back from the query exchange rate for method, which is 1.2, and we end up getting this price for London to New York in pounds. So once again, you can kind of get a feeling for what things look like if you program in completable futures versus RxJava. For my money, the completable futures version is arguably more concise. And the main reason for that is that they bake in the concept of a factory method that starts a computation running asynchronously using the supply async method, which is a single point of asynchronous invocation. Whereas in RxJava, you have to do a couple of extra things. You have to use from callable or whatever, and then you have to go ahead and tell this to subscribe and run on a background thread in the common fork join pool or the computation pool or the IO pool or whatever pool you happen to want to use. So I think arguably completable futures is a bit more concise when you use it for these kinds of things. And this particular example doesn't really use a lot of the other more powerful chaining mechanisms with RxJava. So completable futures is probably the way to go for this kind of thing.